All right, folks, today we're going to look at our last section in systems of equations. We're going to be writing and using systems based on real-world situations, and that's what our essential question says to us. How can I create a system based on a real-world example? All right, so I have one created here. The Valentine's Day dance at Benarsic had 290 students attend. Pre-purchase tickets cost $5. Tickets at the door cost $7. How many of each type were purchased if $1,790 was collected? So you may need to take a second or two to kind of write this down. So if you need to pause it and go ahead and write it down, that's fine. Just like with other word problems that we've seen, the very first thing that we should probably do here is define our variables. So like, what are we missing? What's that information we're trying to find? Well, with all systems, we have our X and our Y. The two things that they're looking at is how many of each type were purchased. Each type is referring to our tickets. So we have $5 tickets, which were pre-purchased, and we have $7 tickets, the ones at the door. How you label that doesn't matter. You can just call them $5 tickets, and we can understand that those are pre-purchased, and then $7 tickets. Those are purchased at the door. From there, we should write our two equations. This has proved to be a little bit difficult in the past, but we have two different types of information given to us. We have our information that's dealing with money, and then we have our information that's dealing with telling us how many tickets were purchased. All right, so if they're telling us how many tickets were purchased, total as 290, but we don't know how many were purchased for $5 tickets and $7 tickets, we could say $5 tickets plus the $7 tickets equals the 290 tickets that were sold in all, since 290 people attended. From here, I can use that information to dealing with the money. $5 for tickets at the door, which is X, $7 for tickets, $5 for pre-purchase is X, $7 for tickets at the door for Y, and that's our $1,790 that was purchased in total. So I could call this 5X plus 7Y equals 1,790. My step from here is we need to solve our system. You should probably pick the method that you feel best to use. Graphing these would be terrible. You could use substitution, but I'm a much bigger fan of elimination. Now, nothing eliminates right away, so I need to get either X's and Y's to the same coefficient, just opposite. So I'm going to multiply the top equation by -5. And that makes this top equation -5x minus 5y equals -1,450. Bottom equation stayed the same. 5x plus 7y equals 1,790. And then we would just go from there. Sorry if you guys couldn't see that. My x's cancel out. My y's, -5y and 7y is 2y. -1450 and 1,790 is 340. So I'm going to divide by 2 on both sides. And y equals 170. So that tells me that we had 170 tickets that were $7 tickets sold. If 290 in total were sold, that tells me 120 $5 tickets were sold. I could write that as an ordered pair, 120, 170, but it's very important to make sure that we have this part so we know exactly what we're looking at. We know exactly what those labels are. That's really all we have here. There's some extra problems on pages 18 and 19 that you can do if that interests you. If not, whatever, I guess. Our movie quote for for today. Sorry, I forgot until the end. It is, I feel the need for speed. All right. If you got any questions, go ahead and reach out. Thanks.